So the first problem says expand using the double distribute method. And here's the problem. 3x plus 2y cubed. So this is how it looks like. You literally do that times 3, so 3 times. And then how we're going to do this is we're going to ignore the first one and multiply out like that. And also like that. So that then equals 3x times 3x is 9x squared. 3x times 2y is then 6xy. Then 2y times 3x is 6xy, and 2y times 2y is 4y squared. So then we leave that like that again, and we simplify down, so we just add the 6xy together. And then we do the same thing, but for the first brackets here. So we multiply out like that, and then multiply out the other way with the 2y. So I just arranged this in a way that's sort of easier to add up, so it's like the same units. So I did those ones there, that line, and then the second lot of the 2y just below, but I lined up the like the same, whatever that is, the x's, so they're equal. So then I just combine them together to get the final answer in standard form. So this is the second problem on the practice test, and it says expand using Pascal's triangle and binomial expansion. So it's the same problem as before, so we should get the same answer, but we will see. Okay, so we have the problem here again with the 3 squared for 3, and the Pascal's triangle is this. So it's mathematical pattern sequence, I don't know, but it's a triangle. It starts off with 1 and it goes down 1 all the sides. So then you add these two, 1 and 1, it makes 2, 1 and 1 makes 2, and then 1 and 2 makes 3, 1 and 3 makes 4, 1 and 4 makes 5, and then so on, 4 and 6, 10, 3 and 3, 6. So it's sort of easy to understand. It's a very cool concept, I think. So here it tells us that it's to the third power, so what we're going to do is that indicates that it's the third row, but then we always take one away, so it's actually going to be the second row, which is 1, 3, 3, 1. So then what we do with that is, what I did was I spaced out 1, 3, 3, 1. And then we get the 3x, and we know it's still to the third power, so we put 3x to the power of 3, and then to the second one we put 3x to the power of 2, power of 1, power of 0. And then we do the opposite with the 2y. So it starts off this end now, 2y to the power of 3, 2y to the power of 2, power of 1, power of 0. So it's sort of reverse. So then what I did here was I simplified and did the multiples. So I did 3x to the power of 3, which is 27x cubed. And then anything to the power of 0 is also 1. So that's just going to be 1. And then so forth. These are all the same. They've all been multiplied out like that. And then I simply simplified them. So 1 times that is 27. And then 3 times 9x squared times 2y is 57x squared y. And then 3 times 3x times 4y to the squared is 36xy squared. Then 1, 1 is going to be the same. Oh, actually that should be a y. I don't know why that's not. That's y. So there, we get the same answer as before. Are you okay? And it says to factor completely this. 5x cubed minus 20x squared minus 45x plus 180. So what we're going to do first is we're going to find out what goes into all these numbers. You can't do x because 180 doesn't have x, so we had to find a number. So 5 goes into all of these. So we're going to take 5 out and we're going to put it out here. And then we're going to put all these in here so that when they're times by that, they equal this. So 5x cubed equals that. 4 times negative is going to be negative 20x squared. That's going to be negative 45x. And then 180. So then within that, we're going to break it up into 2 parts. So these two are going to be broken up, and they're going to have a little add sign. It's going to be, yeah, you can add them. So then what we did is, we made these 2 smaller brackets within this bigger one. And then we took out another common multiple in each bracket. So in the first bracket, it was x squared, because this one has x squared. So x squared times x is going to be x cubed, and x squared times negative 4 is going to be negative 4x squared. And then we're going to do the same here. So negative 9 goes into 36 4 times. So we put negative 4 is going to be, negative 9 times x is going to be negative 9x, and then negative 9 times negative 4 equals 36. So then we have the same, these 2 brackets are the same, which is what we wanted. So we're going to make them into 1, which is here. And then the leftover bits, the x squared and the negative 9, we're going to put them into their own little bracket here. So then we need to factor that out so that it's like bare minimum, like that one. So we know that x squared times together is x and x. So yeah, we put them into 2 different ones, and then we want to make negative 9, which equals that. So yeah, and then we just add the end bit at the end, the x negative 4, and then we leave the 5 outside, and that's the answer in factored form. Find all real solutions using synthetic division, given one possible solution of. Okay, so here's the problem equation, which says f of negative 3 for f of x equals x cubed and take away negative 5x cubed, take away 9x plus 45. Okay, so then here I just reminded myself that f of negative 3 equals the same as this, x plus 3 equals 0. So then I wrote out the problem again so it's clearer, and I simply said which was the common denominator, or the letter that's in front. So x is just going to be 1, and here it's going to be negative 5, here's going to be negative 9, and 45. Okay, then out here I put negative 3, which is from here. So this is the synthetic division method, which Okay, so then for the first one, you just take the first letter, the first number down, and it's just going to be 1. And then with that number, you times it by -3, which is going to equal -3. So then you add these two, which is going to be -8, and you put that down here. And then with -8, you times that by -3, and then that's going to equal 24. So then you add -9 and 24, which is going to equal 15. And then you times 15 by -3, and it's going to equal -45. So then these two cancel out, and it's going to be 0. And then you write them out again, but as there's only 3 problems, you've got 2. That's going to be 2, that's going to be 1, that's going to be 0. So it's not going to be anything related to these up here. So yeah, that's the same. 2x, 1x, 0x. And then we're going to keep this from up here down here, so that's going to multiply. And then, yeah, we put them into 2 different ones. So yeah, we're going to make 2x squared is going to be, so it's going to make x, so that makes that. And then we're going to do -3 times -5 is going to be +15, and then those two added together is going to be -8, so that's going to equal it all. And then we solve these for 0, so we make them equal to 0, and then we make them equal to x. So x equals -3, x equals 3, x equals 5. And then we write them out like this in these brackets. On the practice test, the last question. And it says, when plotting the roller coaster's path on a graph, it shows the y-intercepts where, so these ones are 0, -4, and 4. Write a possible polynomial of the roller coaster's path in factored form. So these are the same thing again, and I just set them all equal to x. So all of these equal to x, and then I set them all equal to 0. And then I just put them into a binomial, so 4 plus x is there, and -4 plus x is there. So that is the answer. But then there's the second part of this question with all these questions. So to find these out, I did a little working here. So I had the answer, and then I just factored this x that's in front of it all into there, and then I got this, and I just cancelled out these two because they cancel each other out, and then the final answer is this, and this is the standard form. So to answer these questions, so yeah, that's the standard form. The classification of this polynomial is a cubic binomial because the highest degree is cubed, so 3, and it's binomial because it's only 2 factors. Okay, and then the degree, is it odd or even, and we can see that it's odd. And then the leading coefficient of that one, which is going to be 1, is positive because it's not a negative, obviously. And yeah, so then we find the y-intercepts and these 2, and we only put 1. Well, there's actually 2 of these, but we just put them as 1 because they're the same, so they don't need to put twice. And then in the roller coaster, if you imagine it as a roller coaster, it's going to have 2 turning points. So yeah.